Hey everyone, if you're going to appear for round two or client round, you can expect similar kind of question where you'll be given a code snippet and you have to find which solid principle is being violated in that particular code snippet. The challenge is not to find the name of the principle because usually we figure out, but the challenge will be to how to prove that this principle is being violated. And at the same time, we have to, most of the time, they will ask you to redesign so that failure doesn't happen. So let's flip to Visual Studio and see and we'll try to reconstruct the similar kind of scenario and try to understand all of aspect which often being discussed during the interview. So if you look at this program.cs file, we have a payment method which is an abstract and it's going to be served as the parent class this system. So we are trying to simulate a real world payment system, right? And the payment method is the parent method where we've got two method. I beg your pardon. The parent method class is the base class which has got two methods, process and refund. Now we have got two card payment method. One is card payment, which is inheriting from the parent class. Now it has its own implementation. The card payment is processed, and if refund is required, it will refund it, right? And we've got another method which is non-refundable payment. Once payment is made, you cannot get the refund of it. And we see a lot of situation like that on any e-commerce website like Amazon or Flipkart, wherever. This also has got two implementation because it is inheriting from the parent method. It has got to implement process and refund. Since refund is not possible in non-refundable payment card, we will throw an exception. Now, this is an important service. This service is only, using payment provider method, which is basically directly, which is not directly talking to any of the child class. It only depends on the payment method abstract class. Now, if let's say we are creating an instance of parent class and pointing to card payment, which is payment method one, and the same thing we are doing for non-refundable payment, which is payment method two. If we build the solution, you see there is no error. Let me try to run and show you that it doesn't give you any build error. Build will succeed. But question was, let's talk about elephant in the room, which was asked in the first place. That which solid principle is being violated here in the system. You see, right? There is a abstract parent class and two child class who is implementing the process and refund method. Since we don't see any build error, which solid principle is being violated here? Let me know in the comments which solid principle you think is being violated here. Most of you would have definitely guessed it right. It's the Liskov substitution principle which is being violated here. Because as per the Liskov substitution principle, any subclass should be usable whenever the base class is expected. This is the simplest definition I can point out. Whenever, object reference variable of parent class is pointing to its child class, the expected functionality of the system should not break. Means a child class should be able to fulfill all the responsibility which was supposed to be fulfilled by the parent. And in the inheritance hierarchy, though LSP doesn't have to do anything with the inheritance, but since it uses inheritance, and that's exactly where the system breaks, object reference variable of parent class, or in other word, object of parent class should be easily and smoothly substitutable with its child class object, right? So here you see the card, which is object reference variable of payment method, and I would strongly encourage you guys to use technical vocabulary. A lot of people uses like this card or something. I don't know. The fact is, this card is object reference variable, and this is the object. So whenever the object reference variable of parent is pointing to its child, the functionality or the flow of the application should not break. Okay. If service depends on a base class, it should not cause any unexpected failure if the object is being replaced with its subtype. Okay, this was the first question. Let's look at the second question, which is also considered tricky, and you should be, in a position where to you should be in a position to defend yourself. Now, if you remember, the next ask was how you're gonna fix this issue. Now, since because the parent was, forcing us to implement both, how can we avoid this? So the best possible way is to split the responsibility. So what we can do, that we will remove this from here, and we'll create an interface. And that interface will be representing this refund method. So whichever class wants to implement this refund functionality will be using that, else it doesn't have to. Okay. So that's how, by splitting this, we have not, now we are not forcing any class. We're not, putting a class with trust that you have to implement it. And that's where this interface comes into the picture. Now this start payment can also, inherit from I refundable, and the refund method is already there, which is already implemented, right? So let's make it okay. So Visual Studio is complaining that there's nothing to override. You look at the error. These error also, you should be keep in mind, because but we will implement it differently in non-refundable one. So now in the non-refundable one, we just simply have to remove this method, because non-refundable one doesn't allow refund. And one more change we have to do is inside, instead of passing base class, which is payment method object, we will be passing um, interface reference out here. And using this, we will be calling the refund. And in the process of this, we will be all set. Now there won't be any error running this code. After these refactoring, let's build and see if there is any error or not. Build was anyways succeeding, so even now it will. And we'll run and see if there's any error or not, which it should not. Okay, everything works right. I'll paste this code in the comment section. You can take it and do some hands-on. I would strongly encourage you guys to do some hands-on, so that these changes, whatever we have done, gets inside your mind. I know majority of the people have already figured out that what will happen, especially when non-refundable one. But if you haven't, then you must have learned something. Those who already understood the problem and realized that it is LSP, I hope at least they have got to know how to respond to these questions and how you should build the interview, right? You should not jump into the answering the question. You should go with the flow, that why I think LSP is being violated and what are the steps we can take in order to fix it. Now that we already have some clarity on how to respond to this question, let's look at some more questions which looks very straight. If you look at from the naked eye, the moment you start answering, unless you have clarity on how the runtime behaves, how different aspects comes into the picture, you usually end up giving half-baked answer or the wrong answer. So one of the question which I got was, two different services are registered for the same interface. So there will be two services which are registered against the same interface in the DI container. Whenever we request for a particular interface, that particular interface, which implementation is going to get injected. So let's flip to Visual Studio and understand this, how exactly things are working and how to answer this question. For the sake of simplicity, I have created three different files. One will be representing our abstraction layer, one will be the infrastructure layer, and the one is security layer. So let's say this is the interface which we are talking about, which two different services are gonna registered against. So let's say there's an email notification service which is implementing this notification sender interface, and it has got its own send method implementation. Same with audit notification thing. It is also, this audit notification sender service is also using iNotification sender, and it has its own implementation of sender method. Now, in order to replicate this, the way we basically register our dependency injection time, lifetime, we have created this module where we are injecting the iNotification sender interface and its implementation, which we just saw, right? This is how we give the life cycle. This is how we register the service life cycle in ASP.NET Core. And here we are doing the same for audit notification. We have seen like audit notification is also implementing this interface and having its own implementation. Right, now let's move on to program.cs file and try to replicate this scenario that two services will be implementing this interface, and they will be registered against this same interface And the moment we, when the interface is requested, which implementation will get injected. So I hope things are clear that one implementation is done by audit notification and the other one is done by uh, uh, email notification. Okay. So let's see, let's flip to program.cs file and check which one will be. Uh, so here's our program.cs file, and we have registered both our services inside it. Okay. So you have to imagine this is a real application where in the program.cs file we are registering both the services. Infrastructure team will register its own service and security team will have its own service registered. Now think again about the question, what it was asking. As we can see, both services are registered against the same interface, right? And that is iNotification sender against this. Now, our problem statement is whenever this iNotification sender interface will be requested, how DI container will decide which implementation to provide. The question is very simple. Okay. So let's say in a real application, controller depends on one implementation. So whenever you implement it, controller would need one, and usually we avoid name confusion, right? So here's we will be trying to simulate the scenario. So that the single is basically representing that that particular implementation of a notification, that single one, which we will find which one will be given by DI container, and how DI container will decide which one should be uh, given back when it is requested. Okay. So if we run the application, we'll see at the end which one will be called, and both are registered at the top, right? Whenever we run the application, how which one DI container is gonna reply to based on the request. So let's run the application and see the results out here. And audit sender. How and why? Let's see here. Go to add security, and add security is implementing audit notification, which name is audit center, and that's exactly what DI container replied to. Now let's flip the registration, you know, sequence. Now suppose we are registering the audit one first, sorry, security one first, and infrastructure one at the last. Now let's again see of .NET Run. As you can see, email sender is the one got resolved. So that gives a very clear picture and proof that whichever service is registered at the last, that implementation will DI container gonna consider to be the final one. So to answer this question straightly, so as we already have seen, the DI container keeps all the registered service and its implementation in sequence. And whenever you ask, it will start giving you from the last one and it will keep on going back. So through this IEnumerable um, loop, let's try to see how it actually works. Thus, this gives us in which sequence it's gonna give us back the result. So let's run the application once again. Let's clear the console and try and see how we get the results here. So as you see the result, first it gave us email sender and then the audit sender, because that's exactly how we have registered our services, right? Okay. Now this question might make sense now. So whenever two different services are registered for the same interface in dependency injection in DI container, when the interface is required, the DI container is going to give you back in a sequence. Now, since we have already implemented this, I think things are very clear now that whenever the DI container is going to return those registered service and the implementation of those interfaces, it will return in the opposite way, opposite direction. It will start with the last registered service and then it keeps on going there. Same. So single service resolution rule. So let's look at the rule. When multiple implementation are registered for the same interface, requesting a single service returns the last registered implementation. Always keep this in mind because I've seen this question, kept on repeating. So why does this happen? Because DI containers store registrations in order they are added. So let's say if you have register 10, then starting from 1 to 10, it will be, it will keeping them stored somewhere. And whenever you ask, it starts giving you from that's why the last one will be sent to you first and so on. And we already have seen how, you know, IEnumerable can help us to extract all the order in the same sequence. The last one will be sent first and second last and so on. Okay. And through this question, you are able to explain to them. And that's exactly what we should be doing because it is giving a clear message or the question, how we are answering. But at the same time, we are also understanding the framework, how DI container actually behaves. Okay. Let's move on to the next question now. Okay, so let's talk about a question which has been coming to me in almost 90% of the interview. Wherever I'm going, this question is being asked because this question literally checks your, ability to relate with CLR, how runtime works, and the execution ordering of constructors actually decides something very important because understanding of different constructors under different environment, when to use what decides a lot. So I think that's why it becomes even more important. But from the interview point of view, it is actually very important. So before we understand all this, let's understand each constructor one by one, and then we'll flip to Visual Studio and understand the exact execution cycle by running the code, okay, in different environment. So let's understand what is static constructor. So these constructors, the reason static constructor is being discussed widely in almost every interview is because it works exactly the opposite way of a normal constructor will work. So it runs only once per type. What is type? Type is interface, class, and everything, structure and all. So it runs once per type. So even before the application, using this class, it will be triggered by CLR. So CLR takes care of executing this static constructor. You cannot explicitly call it, and I'll show you how. And it executes before any instance of this class is being, used or called or whatever. It is being completely triggered by CLR. We don't have any control over. And the one which almost all of the people talk about is the use of for static field initialization. So that's true, but the single answer doesn't satisfy the interviewer because if you answer all this holistically, it gives a very clear sign that you know exactly how things are working. So let's flip to Visual Studio and show me. Let me prove all this point out there. Whatever we have discussed, like whether it runs once per cycle or not, can it be executed even before the class initialization and all? Let's see that in action. So here in program.cs5, I have created a very small class, which is payment service class, which has got a static constructor and a instance constructor. And currently, if you observe, there's nothing out there in the main. Means we are not at all doing anything with this payment service class meaningfully. We are not using it, right? And I just pointed out that it runs once per type. So even if let's say you are not doing anything with this type or class, you will see the static constructor is going to be executed. So let's run this application and see. So now let's run the application and see if that is the case or not. Okay, .NET Run. So once it's run, you see it says static constructor executed. Despite we have not done anything, neither we have created an instance of this class or nothing, but still this static constructor gets executed. So we have proved the point which we talked about, that it will run by default by CLR no matter what, whether we create an instance or not, right? And the second point was it gets executed even before the first type usage. So currently, we are not using this payment service class. Now let's use it and see if that gets executed again or not. Because let's say if we create multiple instances of this payment service class, then multiple, time the constructor will be called if it's an instance constructor. But you will observe that this constructor will execute once and then it will not run again, only once. And other instances, no matter how many instances you are creating, static constructor will have only one execution, but others will have multiple if there are multiple instances. using this class. So let's see in the action. So let's create first instance of this class. So CLR is going to go and check has this type being already initialized or not. If not, it runs the static constructor once again for the first time, and then it will be silent. So let's try and see in the same thing in action. Okay, and I think both the constructor will be called because since we have run the application again, so every time we run again, once per lifecycle, the static constructor is going to get executed, but the instance constructor is also going to get instantiated if we have created one instance. Suppose we create multiple instances. Let's see what happens at that time. Again, we will run the application. So whenever we are running, that means the application lifecycle starts there. So as I already have told you that static constructor will be executed once, and then depending on how many instances we have created of instance constructor, that many time those constructor will be created, will be instantiated. And this is a very important interview point. If you don't clarify this, then you might be in sort of trouble, I can say. And this is going to be a very important interview point that instance constructor gets executed every time we create an instance of the class or type. But static constructor runs only once every per life cycle of the application. So let's run and see. Because we have created three instances, you will see static constructor executed only once. But since we have three instances of the the class, instance constructor get executed thrice. Okay. So I hope that has clarified what is the difference between static constructor and instance constructor, how it so if you understand these basic ones now, then you will never forget. And that's why often you see me encouraging you guys to do and type and go ahead and see that. Remembering and memorizing can confuse you because there are a lot of things we can discuss during interview, right? A lot of follow-ups can come. So in order to tackle them easily, it is very much important that you go and type it. So I'm going to share anyways the code. You please go and play around with this. As we have already said, like it runs one per type. So there is a class, no matter whether we create an instance or not, it will be executed once. Okay. Now, yeah, when is a static constructor get triggers? We have already seen, no matter what we do, it will be triggered. Any mean, whether you create an instance or not, it will be triggered if that class is going to be used in your application. Okay, and because it's the CLR responsibility. CLR. So, and one more thing, let me point out, very important, that the moment you hear the word static, that means that static keyword, whether it's a constructor or a variable, static variable, everything will is going to be handled by the class itself. That constructor or that variable belongs to this class, not to the instances of the class. Normal constructor or normal variable belong to the instances of the class. So that's why it's a very important point you can raise during the discussion between static versus singleton. That static is a keyword belongs to the type or to the class, but normal one, instance one, does go instance one belongs to the instances of the class or type. So that's a very interesting and important point. Just to clarify one more time, what is type versus instance? Type is loaded by CLR, class, enum, structure, interfaces. These are loaded by CLR. Okay, it belongs to type metadata. It has got static fields, static constructor, and it will be initialized only once during the entire application lifecycle. That is very important to be remembering. This point is extremely important. These 4 points. So please take a snapshot of this and keep it saved somewhere, so that whenever this kind of things often comes up in the interview discussion, and just because we might recall or might not be able to relate at that time, that gives a very wrong impression that you might just have coded or used it, or maybe you're not a developer, you've been in a support project or something. So here's the thing. So CLR loads the type. The type gets initialized only once, but instance part will be initialized by the instance of that class, right? It will be having an object memory. It will have instance field, instance constructor, and it will be created through new keyword. And heap memory is the one which takes care of object type or reference type in this regard. So whenever you create a reference or whenever you create an instance of that, That class type, class or type, all the reference type will be stored on heap. That's a very important part as well. So it allows multiple multiple object in the application lifecycle, and all those different instances or multiple objects will be used the way they want them to. But static is the one typically gonna, you know, kept completely attached to the class or type. That it will not, nothing can take control over of that. Only CLR is the one can do anything if at all, right? And there comes a protected constructor. This is also interesting. Let's talk about it a bit. Now, this constructor all of us are using, and make sure don't take a random example, because currently if you're working with let's say .NET Core, then all of us are using the base keyword. If you remember, or if you have observed, whenever you're, let's say, trying to create a what we call whenever you create a controller, right? We often inject the dependencies through constructor, and we use base keyword. Exactly, the protected keyword is being used. So whenever, let's say, a random question comes to you, have you used protected keyword? Where exactly have you used or protected constructor? This is exactly the part. So that's why, if you observe, I always try to take example of, real world industry that we use. So try to substantiate your answers often with these kind of keyword, not indirectly or random kind of bird, car, and all. Whatever we have used, all of us are using these constructs, right? It's just that we, at the time of interview, we might not, we might not able to recall. That's exactly how you should be delivering while explaining in the interview. And the concept which you should always remember is it is a instance constructor. Protected protected constructor is an instance constructor. We can have multiple instance of these type of constructor. But the trouble is it cannot be called from outside. Okay, it does allow inheritance. It forces controlled object creation. Means you cannot randomly create the instance of this from outside. Only those class which might be inheriting this, that has got to be, if at all they want to use it, it will be used through the base. Means the final decision is, we are giving it again back to the parent class construct. We are not directly misusing it. So the balanced use also comes into the picture when we are using protected construct. And the framework is widely using this, and we all have seen in our code. Okay. And the last thing is public constructor, which is wide and open for all. Anyone can use it. Anyone, it basically is the entry point of object creation. The moment you create an object of this class or any class which has got public constructor, the object initialization starts here. The moment you create an instance, it is because of this constructor. We are allowed to create instance. So it executes after the base constructor, and it is the part of constructor chaining. So if let's say you have multiple constructor, it will be chained one after the other. Okay, it will run per instance. So let's say if you have created 10 instances, it will run 10 times differently the way you want to use them. And now let's have a look everything at once. Okay, the holistic picture. Here we've got a payment service which will act as a base class for our example, which has got a a static constructor and a instance constructor. And there is a UPI payment service which is inheriting from payment service, and that has also got a static constructor. And this, the usage I've already explained that it might be used for static variables initialization within here. And there is a derived instance constructor. How these will run? Obviously, static will run only once per life cycle, per derived type, you can say, and it will be triggered by CLR. And this one will be instantiated every time the object of this class will be created. And here, what we are doing, we are running for the first time. Let's say if we are not touching anything, if we comment out all this. So again, let me comment and show you and prove you that again, you will see the static constructors being, you know, run. They are going to run. Okay. Let me show you that, and then we'll uncomment those parts and show you how all these constructor will run one by one. And the execution should stay with you always. Okay. Okay. Now we have commented everything out here, and let's try and run and see how CLR. Okay, so now let's run the application and see what actually happens. How each constructor, gets executed, and under which in which sequence they actually get executed. So let's run the application and see. So let's observe this very carefully. What is happening? The static constructor of UPI payment service is executed. Okay, because we were creating an instance of this means for the first time we are touching that class, and then payment service is being initiated, base type, then protected, and then public. Okay, in the second run only protected and public is going to run, nothing else. Since these are static one, it will run only once. And before we move, let me explain last thing, which is a very important observation. You see here, the UPI payment service derived type static constructor got called first, and then the static constructor of payment service. Why? Because if you observe in the program class, we are creating the instance of UPI payment service first, and the moment it reaches here, it needs to initiate this, right? And through this, it will go to the and through this constructor, it is calling the base, which is this. So there is no strict rule. A lot of people get confused here that base static constructor has got to be executed first, which is not the case. It will execute as we have defined or used in our program class or wherever we are using in the application. I hope this clarifies everything here. That in mind, thank you very much for being here. And I would request you, please, please, please comment down your toughest client side interview question which you have encountered. And also, please like and add some comment. It will help reaches out to me, more .NET C# developers. It takes so much while being in a full-time job to come up with these kind of content. Keep supporting, keep sharing the channel, and let me know if you want a specific discussion to happen. Maybe this weekend I'll be free. So I'll conduct a live session where I can do the resume update, resume review, career suggestion, and we can discuss a lot of things. So let me know everything down in the comment. Thank you very much, guys. Thank you very much.